Just a quick overview of what we're going to talk about. Kind of first give an architecture overview about all the moving parts involved with using C++ on iPhone and Android. Just all the languages involved, that kind of thing. I'm going to introduce you to the Dropbox tool Djinni and kind of go over what it does, the workflow involved, and that kind of thing. Then we're going to go into the examples. They're mostly high-level architecture examples. There will be some code on the screen. Try to keep that to the minimum, but and I've also tried to keep the functionality to an absolute minimum, which is going to be strange because we're going to a lot of trouble for minimal functionality, but the idea is you can expand the base level architecture into a much more complex app and combine some of these methods and that kind of thing. The first three examples are all demonstrating the different ways that Java, C++, and Objective-C talk to each other. The last example goes more into data structures and passing data objects around between the languages. To wrap up, just going to go through some random challenges that I encountered and how I resolved them, and point you to some additional places on the internet you can go for more information. All right, so let's get started. So, high-level goal, we want an iPhone app and an Android app that use a C++ library. Why do we want to do this to begin with? A lot of it, my main reason is for the dry philosophy, don't repeat yourself. There's a lot of code that goes into apps that doesn't need to be coded in Objective-C and Java. We can abstract that into C++ and reuse it for both platforms and kind of just concentrate on UI for Java and Objective-C development. Another reason, if you're into unit testing, you can unit test once all your C++ code before it goes to the different platforms. So that's delved a little bit into that, and it's worked out pretty well. Performance, C++ is known for performance. So depending on what your app does, it may benefit from using some C++ libraries instead of the Objective-C or Java equivalents. And just the sheer amount of open source libraries available in C++ is somewhat of a motivation, like, for example, Boost. Okay, so what are our goals here? We already talked about it a little bit. We want an iPhone app. And we're going to code all our UI in Objective-C or Swift. I'm going to focus on Objective-C for this talk, but it is possible with Swift as well. We also want an Android app, which we're going to code in Java. They just announced Kotlin, which I have zero experience with, but in theory that would work. If you can have a project with Java and Kotlin, you should be able to do this. But I can't guarantee that. And finally, a C++ library that talks to both. And kind of other goals, move anything we can to C++, so we only manage it in one place and update it in one place, and utilize that library on both iPhone and Android. All right. Just a kind of a quick little few bullet points about what should and should not go into C++. So if you have your cloud API requests and responses, it's a good opportunity for C++ to do that once and then send data to Objective-C and Java. Any sort of SQLite database logic. iPhone and Android both have access to SQLite, so we can handle all that in C++ if we want to. If you have really complicated calculations or algorithms or anything like that that isn't, it happens behind the scenes, behind the UI, C++ might be a good opportunity for that. And pretty much anything we can do with a C++ library. OpenCV is a good example, that kind of thing. So now what doesn't belong in C++? This is sort of my opinion. I know that some of these things could go there, but Okay, so user interface and animations. I actually like to use the native, iPhone tables and the Android tables. The platforms spend a lot of time making those really smooth and animated, and I just assume keep that. There are some platforms that you render the whole app in JavaScript, and then your animations and that kind of thing gets a little wonky. So this technique, we get to use Apple's table views and that kind of thing. So I like that. App Store logic is obviously going to be different for Android and iPhone. You can do a little bit in C++, like unlocking content, that kind of thing, but for the most part, we have to go back to iPhone and Android to handle that kind of thing. Sensor, camera, and input. Some of that you can get through C++, but it's a lot smoother to just use the input from Objective-C in Java and then process the data or whatever you need to do in C++. Okay, so let's go through an overview of all the languages involved. We already talked about 3. C++, iPhone, coded in Objective-C, Android coded in Java. So those things don't talk to each other by themselves. You can't instantiate just out of the blue a C++ object and start calling methods in either Java or Objective-C. But there are what we call bridge languages, which is what we're going to use. So on the iPhone side of things, we have an Objective-C bridge built with a language called Objective-C++. On the Java side, a Java bridge built with Jni. So this is kind of one of my favorite questions. Show of hands, has anyone had to ever deal with Objective-C++ or Jni? A lot of people, okay. So how many of you had an awesome time with that? That was like your favorite thing you've ever done with a computer? Okay, maybe either one. Okay, all right. So Jni, not so good. I can only speak for Objective-C++, and I was trying to use the OpenCV library on iPhone, and it was before I kind of discovered Dropbox's tool and all, and it was a mess. I had code in all kinds of weird places. I couldn't tell where Objective-C ended and C++ began, so I was renaming files to make them work. So it was pretty gross. I didn't like it. So that's pretty much common theme is people don't like these languages. So they suck. They're very error prone. They're difficult to troubleshoot if you get this crazy stack trace and somewhere in the middle you have this nonsense Java function name that has a package in it. I don't know. There's a lot of weird stuff that can happen trying to troubleshoot this. There's little to no documentation. I feel like the Objective-C++ documentation was removed or something because I don't really find much about it online other than Stack Overflow and whatnot. And it looks gross. We're nice, tidy programmers. We don't want to deal with gross code. So we don't want to lose heart yet, though. So we have this architecture with these bridge languages, and what we're going to do is we're going to remove them from the situation. They'll still be there, but we're going to generate them automatically using a cool tool called Djinni. So just from like a developer team standpoint, this is a lot more appealing because all the languages we're going to use are languages that people actually want to put on their resume. I don't know about you, but I wouldn't put the other 2 on my resume. Okay, so let's go over Djinni. Well, first of all, any questions before we move on? Good so far? Okay. So let's go over Djinni and what it does and how it can help us. What does it do? It takes in basically a configuration file called an IDL, Interface Definition Language. We can define interfaces, enums, that kind of thing. The main reason we want it is it generates interfaces for us for each of the languages that we care about, Objective-C, Java, C++. It gives us an interface for that we just fill in the methods, and that's all we need to worry about as far as our language branch is concerned. and it automatically generates all the stuff that happens between those. So we don't ever have to see it. So Djinni deals with 3 types, kind of the higher level, like the top level types of things it will generate. So enumerations, records, and records can have name properties, everything you would expect, bools and strings, lists, maps, and other records as well. So you can get a pretty complicated data structure with Djinni. Generates interfaces, which is mostly what we're interested in. So this is going to allow us to send methods back and forth between these 3 languages. You can add constants as well. The main thing missing here is properties. We're not going to really be able to build an interface with properties unless we build our own methods to get and set them. You can get around that by using private members in your various implementations of the interface. And so your methods can have arguments and return values of all the same types that the records can, the record properties. Quick little clarification. So there's another tool that deals with IDL files and generating code for all these languages called protobuf. So I wanted to kind of compare these 2 things real quick. So they have different purposes overall. Djinni's really focused on iPhone and Android development. There's just the languages involved there. Protobuf supports a whole ton of other languages, PHP, Ruby, and it's more focused on the data structures themselves. So they both do data structures. Protobuf actually generates the getters and setters for you, so you kind of get that member feel, but it's not an interface though. So you can't make methods with protobuf. Djinni, that's primarily what we're going to be doing, is calling methods back and forth. Okay, still no questions? Any questions? Good. So first example. Again, I'm trying to make the functionality as minimal as possible just to keep things simple. There's no reason you would need to do all this to say hello world on an app, but we're going to do it. But you can kind of extrapolate this architecture into a more complicated app. So what are our goals here? We're going to build the hello world logic in C++. We're going to init the class from Objective-C and call the method. We're going to init the class from Java and call the same method. So reuse the library, get a hello world, and we're good. Architecture. Start with iPhone. We've got the iPhone UI. The iPhone, we're going to automatically generate the C++ bridge. We're going to pass through the bridge and call a function on the C++ library. Android, same thing. JNI bridge, C++ library. So the important thing here is the arrow is one way. Right now, all we're doing is from Objective-C and Java calling a C++ method. C++ is not calling Java or Objective-C yet. I wanted to clarify because I'm going to use the word interface a lot, and it's more of a high-level architecture kind of perspective. It's not what they actually are. So when I say C++ interface, I'm talking about an abstract class with virtual methods. You can see on the right, they've got the virtual keyword equals 0, kind of the typical interface sort of situation that a C++ developer would expect. Objective-C is a delegate, much like a UI table view delegate and UI table view data source. Again, something that an Objective-C developer is really used to seeing. Finally, Java is another abstract class. So when we extend that class, Android Studio is going to complain and want us to implement all the abstract methods. So for now on, I'm just going to call all those things interfaces. So let's get into our first IDL file. Pretty simple syntax. Looks vaguely like JSON or something. A couple of notes here. So we're creating. Sorry about that. Be less easy. So we're creating an interface. That plus C indicates what language we want the interface to exist in. So right now we're just telling it to build a C++ interface. This create method, it's getting around lack of constructors, kind of. So it's a static method that returns itself that we're going to call from Objective-C in Java. Finally, our method that we're going to call from both Objective-C and Java returns a string. Pretty straightforward. Now the fun part. We're going to run Djinni. Djinni is a command line tool. You just open up console, type in a command. Usually make a shell script because there's actually a lot more arguments involved. You can specify all kinds of things like what directories you want the different languages to go in, if you want camel case or snake case, that kind of thing. And more importantly, you can specify namespaces, you can specify the Java package name, you can specify the Objective-C kind of prefix that's common with Objective-C. Okay, so we run this script, and what do we get? We get a bridge code. It goes in a directory. We're never going to look at it. It can just stay there. And the one thing we do care about is it's going to generate the C++ interface that we have to implement. Quick Cody slide. Okay, so on the left is the auto-generated interface. So you can see the virtual methods that we have to implement, that kind of thing. So our implementation files, the header imports that interface, implements it, and declares that we're actually going to implement the get hello world. The CPP file has a couple things going on. So it implements the method hello from C++. We're cool there. It also has that create method, which is a little strange because it adds it to the interface. But I can't really explain how all that works, but it does work, and that's the thing that we'll call from Java and Objective-C. Okay. So now we're in iPhone world, and this is our view controller. View controller is kind of the thing that represents each view, and where a lot of your logic exists for all kinds of things. The view did load, that's kind of the init method. Up there at the top, so the HWCPP API.h is also a class generated by Djinni. It is a full-blown Objective-C class, and it behaves exactly like we would expect. So we have a private property for it. In the view did load, we create it, and then we call get hello world and send it to the console. Java, similar situation. We don't have to import anything because it's in our hello world package name, which we would have configured in our Djinni command. I didn't show that, but that's what that would end up doing. Private variable for the API, and then our onCreate method, which is similar to the Objective-C. We create the API and then call it get hello world, and it should go out to the console. How's everyone feeling about that? So far, so good? Okay. Okay, so these examples are going to build on each other, and I'm going to avoid repeating any of that. So I'll only show you the new things from now on. Okay, so example 2. Our goal here is going to be to access this bridge and logic in Java and Objective-C from C++. This comes up a lot, and the example we're going to use here is Android and iOS both have a separate API for setting a quick and dirty user preference, just a key value pair, different data types, that kind of thing. We're going to store a string, or no, we're going to retrieve a string from Objective-C and Java. So, recap. Call a Java function from C++. Call an Objective-C function from C++. So what's that going to look like? It starts out pretty similar to our hello world. The UI passes through the bridge and calls or instantiates the C++ class, that kind of thing. So when our library wants to go back over the bridge, it's going to go through the Objective-C interface, or the delegate, and also the Java interface. So these are things that Djinni is going to render for us, and we just implement it in our apps wherever we see fit. So how do we actually do that? So previously, in Objective-C and Java, we basically instantiated a C++ class. That's not really a great way to say it, but from our perception, that's what we did. But we can't do that backwards, right? So if we're in C++, we can't create a Java object because we don't know if we're going to be in Android or iPhone. So we do something with that I'm going to call a listener. So this is from Java's perspective. We create a listener object first. We pass it to our C++ object with a create method. So listener is now, there's an argument listener that we instantiated in Java. And finally, in C++, on our create method, we would save that listener as a private variable. And throughout that our whole API class, we can call our getPreferences function. And C++ doesn't care if it's Java or Objective-C. It works out really well. So let's write our IDL file this time. There's a few different things to look at here. We have two interfaces, first of all. So we've added an argument to our create that actually, the value of which is our listener. And our listener now has different, we're telling Djinni to make it in different languages. So we're telling it to make an interface in both Objective-C and Java. So now we run our Djinni command again, the fun part. And what do we get? We get our bridge code, goes in a folder, never look at it. We get our API interface again for C++. And now we get Java interface and an Objective-C interface from the preferences listener. Okay, so now we're going to implement this in Objective-C. Above, so we import the listener interface. We create an NS object that conforms to that delegate. And then down below in our implementation, we implement the getPreferences function. So below that, the NS user defaults, that's the iOS way to get that quick and dirty key value pair. So then we get the value and return it. So Java, pretty similar. We don't have to import anything because it's in the package. So we're extending that prefs listener, which is a Java interface. And our implementation implements getPref. So the shared preferences, or get shared preferences, is Java's way of, Android's way of getting a quick and dirty key value pair. So we get that, return it, we're done. There's the app context is another thing they have to deal with for Android, since we're not extending an activity, but you can just pass in a context and call all the methods you need. Okay, so that was the user preferences example. Questions? Anyone? Sorry, there's one more slide. Okay, so C++ interface now has an argument. So our create method takes the interface argument. So it could be Objective-C or Java. It passes it on to its constructor. We save it, and then later we can call get preferences. And we can do that pretty much anywhere in this class. So this is just showing creating with an object real quick. So very similar to before, except with the C++ create method, but now we instantiate either an Objective-C or Java object to send to C++. It's worth noting that we're using alloc init and new, because we're initializing Objective-C from Objective-C and Java from Java, so we can just do it the normal way we would always do it. Okay, next example. Now we're going to get more into something that you might actually want to build. We want to implement Google Analytics on all of our platforms. So we're going to add TVs here. So we're going to do iPad, iPhone, Android, and then Android TV and Apple TV. So we're going to kind of pretend that we have a really complicated app API, and at some point we do something like we call our web API. It returns some user data, and we set some values like, are they a subscriber? What tier of subscription are they? That kind of thing. Are they paid? Are they free? Whatever kind of something we would want to tell Google Analytics as a dimension, so to separate users. And this logic happens somewhere in C++. So we need C++ to tell Google Analytics a custom dimension or something like that. We're going to use Google's libraries if we can. So there's already an Android library for Google Analytics and an Objective-C library for Google Analytics. And finally, the reason for this example is so I can demonstrate a use case for generating all three interfaces. So let's take a first stab at this architecture. Android, we're going to separate the TV UI from the Android UI, cross the bridge, and talk to our app library. It can be same. This app library is not going to change. It's going to be the same for all of these things. It's our C++ library. We're going to go back across the bridge to our Java interface, which is going to talk to Google's official library. All right, pretty cool so far. So let's try to do the same thing with the Apple TV and the iPhone and iPad. So separate tablet and phone UI from the TV UI, cross our bridge, talk to C++, come back across the bridge to our Objective-C interface. Also, the Java interface and the Objective-C interface, when we implement those can be the same on both the TVs and the iPad and iPhone. And now we're going to talk to Google Analytics for iOS, but there's a problem. If you try to import Google Analytics for iOS into Apple TV, you will get an error. It can't publish because it doesn't support UI WebView. So now we have to kind of think of something else to do. First thing we're going to try is just keep everything in C++. So we've got all our UIs, crossing the bridge, talking to our C++ library. Our C++ library can just talk to Google. There's a reporting API you just send requests to, and it'll log everything. And you can send it all kinds of parameters like your app name, your Java or your app version. You can set custom dimensions. You can do pretty much not quite everything, but a lot of what you might want to do. I think it was originally intended for things like Raspberry Pis and stuff that don't have a web browser. So this makes programmer Steven pretty happy. We're reusing everything. Everything's talking the same way, but it doesn't make businessman Steven happy. So when you go into Google Analytics and start poking around at device information and that kind of stuff. Some stuff's missing. So we want to go back and try to use the Google libraries wherever we can. So we're going to combine the two things. Android. Android was always fine, so keep it exactly like it was. Apple side of things. So iPhone and iPad separated from TV. They're both crossing the bridge. It's the same library, but I had to separate them for just aesthetics. So iPhone and iPad, back across the bridge, interface, Google Linux for iOS library. And now Apple TV. What do we do there? We eventually get to the reporting API we were just talking about with the C++ solution. But now we've included another interface. So in between our library and the API, we're going to build out an interface that matches all the other interfaces. And as you can guess, Djinni is going to do this for us. They'll have all the same methods, and as far as C++ is concerned, they're all going to be the same type of object. So what does the IDL file look like for this? So down below we have the API that we've been creating. One difference here. Wait, let's see. Okay. So the top part. So our listener now has all three objects. So it's going to create a C++ interface, Objective-C interface, and a Java interface. They're all going to conform to this interface, which has the overly simplified track screen. It takes a screen name. And then our interface now has, so the listener, we don't actually need that create method weirdness, because what's going to happen is we're going to instantiate the C++ object in C++. So we can just do it the normal way we would always do it. Finally, you notice our API has two different create methods now. We can't really do overloading, so we kind of have to rename things. So one takes an argument, one does not. So the top one would be for iPhone, Android, and whatnot. The bottom one would be Apple TV, which is going to default to C++. Run our command, similar to last time. So bridge code, never look at it again. C++ interface that we implement. And then finally, for our listeners, we have three different listeners, all of which have the track screen method that we have to implement on each platform. So now let's look at the C++ API implementation and how we handle the listener. So now we have two of the create methods that return the API itself. The top one is for Apple TV, so we instantiate our listener as a shared pointer, pass that to our second create function, create with listener, and our constructor saves the listener like we did before. And now that listener track screen can happen anywhere in that API. Any questions about Google Analytics? Okay. So this is going to be the last example. So right now, so far we've only talked about interfaces and methods, talking to each other with methods. MapPins is going to talk more about data structures, which we can also do with Djinni. Thankfully, it's a lot more simple. So our goals here are, we're going to architect the data structure with Djinni in our IDL file. We're going to pass data objects between C++ and Objective-C, and pass data objects between C++ and Java. So our architecture, it's pretty similar to the hello world. We don't need to go back to Android or iPhone at this point. IDL file. So we have our API, much like we did before, create, and we have two methods, getPins and addPin. GetPins returns a list of pins, and addPin takes an argument of a pin. So down below is, we haven't seen this yet. This is one of Djinni's other types, which is a record. It's basically just a list of values and, names and their types. So for a map pin, we have a label, longitude, and latitude. Oh, right. So record, we didn't have to specify what language, because no matter which method we call above, get pins or add pins, we're going to need it. We're going to need the record in all languages, Objective-C, Java, and C++. Run our command, bridge code, tuck it away, never look at it. Our C++ API, which you have to implement, and then our different data objects. So C++ is going to be a structure or a struct, and Java and Objective-C are both going to give us objects, which we can handle just like any other data objects on those platforms. I'm going to spare a bunch of code here and just show you what it kind of looks like creating objects in each platform. So there's our struct, there's our Objective-C init, a data object with the arguments, and Java initiating an object. And back to kind of one of the good things I like about Djinni is all three of these things are very familiar to these different, like if you had 3 different developers, all those things would be very familiar to them. As crazy as Objective-C looks, like that's how you initialize things. Okay, so now that was all the examples. Any questions? No questions. All right. So I'm going to kind of talk over some challenges I've encountered doing this and my solutions to them, and possibly maybe get feedback from you guys. Maybe there's better ways, or maybe there's something I'm not thinking of. I got really tired of bullet points at this point, so it's just going to be titles, me talking, and some monsters from D&D to help me talk. All right, so namespaces. I ran into this problem. So Djinni allows importing other Djinni files. I ran into this problem when I say like the analytics library. I wanted to have that separate and use it in 2 different apps. You would think you would want a namespace for your library, a C++ namespace for your library, a C++ namespace for your Java, your first app, and a different namespace for your second app. That didn't work out so well because when you want to start doing the listener type stuff and reuse some things, the different namespaces can get a little messed up. So my solution was to just stick with app 1 namespace and app 2 namespace, and the library just gets either namespace it needs. It's all generated automatically, so it doesn't really matter. There might be a better way to do that. So that was one of my issues. So architecture woes. It gets complicated when you try to separate things, much like the libraries or just functionality in one app. How do all these things talk to each other? So you can have a gigantic app API with all these methods, and you could instantiate other C++ things inside of that. But again, you have that gigantic API to deal with. You can also have multiple APIs. So in Java, instead of just initiating that one API, you can have 2 or 3 different ones if you could separate your app logic like that. But then when it comes time for them all to talk to each other, where does that responsibility go? I would prefer it to be in C++, but I usually end up with it somewhat in C++, some on the native side. But it's just one challenge that you kind of have to think through. And at first, I'm like, Djinni's awesome, like kind of architects for me, but there are more problems. Database ideas, this was kind of frustrating to me when I was using the data objects, like the map pin example. So if you make your like CRUD interface, like create a record and all that kind of stuff, with a new record, you don't have an ID. So I ended up having to kind of do 2 different structures, which I wasn't totally happy with, one with an ID and one without an ID. Some possibilities there are passing like null or 0 or something, but I don't know. So multiple implementations. This isn't really a problem, but it is something that kind of helps. So back to the Google Analytics example. Say you wanted different things to happen on different platforms. Say you needed to go back to Android and iPhone to get the user agent string of the browser. Well, Apple TV can't do that. So you can create a separate, and you can't even have, the way to get the user agent string is to, on Objective-C, is to instantiate a web browser and kind of get that property out of it. So you can't do that on Apple TV. So the solution there is to have just a separate implementation. They can actually extend another implementation and just, you can have several layers there. And for Apple TV, the solution there was just return a string that isn't a user agent string. So boost file size. So, this might be even our motivation to use Djinni and a C++ in our app, is there's so much functionality with these third-party libraries, particularly Boost. Boost is huge. And I ran into this when I was trying to convert one of my apps into an Android Instant app. So Android Instant apps, you break apart your Android app into little pieces, components, and then in theory, the user doesn't have to go through the App Store to get your app. They can just click a web link, they download a little piece of the app, they're in the app with functionality, and then later they're prompted to download the whole app. So one of the requirements to do this is each piece of the app has to be under 5 megabytes. So when you get into C++ world with that, you already have some file size just from going to the native language. And then Boost on top of that was like a megabyte or 2, I wanted to say, so there just wasn't space for it. But if you're doing like a larger app that you don't need to worry about instant apps, then probably okay. So main thread, I ran into this just kind of calling C++, actually a timer is a good example. So calling a timer for C++, and then timer ends in C++, goes back to iPhone and changes something on the UI. You have to be careful to call things asynchronously and not on the main thread.
Question.
Yeah.
Tell C++ world, this is this thread, this is that thread. Do those things on thread A, do those things on thread B.
I don't know that I can answer that question perfectly, but so Boost ASIO has several different threading libraries, and on the kind of iPhone side of things, I can speak to, you can specify when you call C++ what thread it's on. So you wouldn't do that in C++, you would do it before you called C++. Does that make sense?
Yes.
And you can also do that around the responses from C++. So actually a better thing to do is when you get the response from C++ and you're going to change the UI, then put that on a different thread. Okay, so some additional resources, in case you're interested and want to get into this. So getting Boost into all this stuff can be a little bit of a challenge. For OS X and iOS, there is a pretty good build script that just builds libraries and then you drop them into your Xcode projects. tvOS, at the time, so this was maybe a year and a half ago when I was trying to do all this, on tvOS there wasn't, it was kind of a funny story. I spent like a couple days, like Thursday and Friday, 1 week, working my tail off trying to get Boost into tvOS. Closed the laptop on Friday, had my weekend, came back Monday, did another Google search, and this thing appeared. So, and this was like right after Apple TV was released too, which is kind of one of the things I didn't go into about why I do this is I can be on a platform as fast as I can. If you were doing something like Xamarin, you might have to wait for Xamarin to update. So the last link is actually an alternate NDK for Android. It has several useful things going on with it. It has just basically better C++ support in general. Although now Android has come a long way. as far as their support. And it's pretty easy to, I think it even comes with Boost. There's a little bit more configuration you have to do, but it's kind of all packaged up in the NDK. So other links. There are 2 GitHub repositories up there. There's the official Djinni one, and there's also this project called MX3. It's a little out of date at this point, but it does have some pretty good examples of that listener architecture I was talking about, and just kind of good practices in general. A lot of what you saw today was based on that repository. Mobile C++ tutorials. It's my website. It has tutorials on it if you want to check them out. There's also a really good Slack channel, Mobile C++ Slack channel. A lot of the Dropbox guys hang out there and answer questions and all kinds of stuff. So that is about all I have. Does anyone have questions or comments? Yeah.
So if I want to return the entire class through a callback, so the simple example was, yes, I got your information, here's a string that you wanted to call back.
Yep.
What if I wanted to return a big object? Does that, can I return something stack located? Does that have to be through shared pointer?
I think
I saw shared pointer being used.
Right. So that is a result of the actual interface that Djinni generates for us. Like already has that create method with shared pointer. So it's kind of enforced by Djinni. As to passing around other objects, you could do it exactly like we did our listener.
When I call back into Djinni, it's like, look, instead of returning a string, I'm returning a whole new object.
Right. Oh, a C++ object.
Correct.
Do
I have to make sure that and return it?
Yeah, so I've never needed to do that, but I think if you do the same thing we did with the Google Analytics example and make the interface in all 3 languages, you can pass it the other way as well. That's a good point, though. I've never tried that. Yeah?
How complicated or how gnarly could your records be? I saw there was like a list of strings. Okay, well that's simple.
Right.
Vector of map of string to list and like that.
I've never tested the limits, but it can kind of get as gnarly as you want. Again, you have all kinds of data types. You have lists, you have maps, and the one weird thing is they're only 1 level deep. So if you had a property that's another record, like say you had an enumeration that was a job title, and then you had a record that was an employee, like you couldn't declare those things inside of each other. That was a bad example. Like if you have another record, they're just 1 level deep. So if you had a really complicated record, it would actually be a long file with separate records.
Other than that, you think like vector of maps can be done? Or maps of vectors, like map of string to vector of whatever.
Right. I think so. That's something I'd have to try. I don't know. Okay, well, I guess if there are no more questions, we can wrap up early.